for a cluster to be made on a 26 node of cluster to be made on a virtualized environments, we would be requiring a physical server, and each VM is to be hosted on the VM on the physical server. So there has to be 26 physical nodes and a VM produced onto that physical server. So there has to be requirement of 26 physical server, which obviously I'm not sure any organization would suggest that, because we have a very limited availability of the tools, and the cost involved is high in this case. I think you must have heard about Facebook. So Facebook has a highest cluster node environment in the world. It has 1,200 node of cluster, which they are currently generating, and they have the lab in San Francisco. So complete 1,200 nodes of cluster. So one goes down, the other gives the service.
So just a follow-up question, sir. Basically when we see the mobility domain, so 1 GB is also very high data, typically. But whereas we are from the healthcare background, so for us any image data is typically like 2 GB is very small data. For us, if it is like huge, when we talk about TBs, that's when it is like large. So is like, do you see that any challenges there in addressing the definition of big data, having any dependency on the domain assets that we are trying to address? And for another question is, how difficult is it typically to simulate a customer environment in a testing environment typically?
And we are from the telecom domain, and we are talking about that. So I'm sure you must be getting confused between these two things. The data from the healthcare we generally have in the
domain is still clear, but I'm talking about the volume of data.
Yeah, that's what I'm saying. Yeah. The data which we get from the healthcare is maybe in the form of a document or in the form of Excel sheets. You want to say something? Okay, maybe in the form of a PDF, maybe the whole a customer is there, a patient is there, patient has a brief history been written on the document. So the data variety is also different as compared to a telecom domain. So obviously the data size would matter. In telecom, there are many people who are generating data each second, each minute, and a lot of obviously the capacity will go high from this to this when compared to healthcare. So there is no specific definition across the domain. I would say it depends from domain to domain as well. And to answer your second question, can you repeat your questions? Sorry for that.
Sure. How difficult is it to simulate a customer environment? Are there any challenges that you face to simulate typically a customer environment in-house?
Practically, it is I would say ideally it is not possible to simulate a customer environment in a test environment. Obviously, there are many challenges which we are talking about in this. There are many challenges apart from that. It is not only the test data or test environment. These are the main significant challenges which are being we are giving an overview to you right now. So simulating needs. Like I said, for a 26 node cluster, we would be requiring 26 physical machines, which is obviously not possible in a test setup. And the customer has a live traffic onto that. The exact traffic would accumulate a lot of CDRs, and we would not be able to take the copy, or because the customer, let's say a customer is there in some US location or a Canada location, and we're sitting in India. So bringing that data from a customer location to our test location is also a challenge, which can have some impact on ideally simulating the environment. So it's really not possible to simulate the customer environment. I hope I have answered your question.
Yes, sir. Thank you.
Thank you. Okay.
You had mentioned about functional testing, right?
Yeah.
How is it really different when compared to the standard functional testing that you do with I mean, in the context of big data, right? Is there some focused attributes or elements that you test from functional versus
functional versus performance, you are saying?
Performance, I do understand.
Okay.
It's clear the functional part, right? And how is it different from big data standpoint?
Okay. Well, to answer your question, I mean, is something we have some requirement. Let's say I have to build a GUI, a bank GUI. Let's suppose we are aware that we have to make a login block and then a password block, and then there has to be some submit button. So we don't have any other requirements about it. So we have a fixed requirement. If we do not go by the agile methodology, because in agile methodology we say that we constantly receive the requirements from the customer at any point of time. Maybe at the time of delivery, we get the requirements. Obviously, we can scope into that iteration or not. That is a different scenario. So a normal functional testing has a limited scope of testing, and in big data testing, we might not have a fixed requirements. There might be or might not be. And in normal functional testing, we do have a fixed requirement. So I have just taken a simple scenario over here.
Is there any specifics, or is it the same? Because that you look from the data per se that you're validating, or is it just
okay. I'll have to go beyond my answer then. For a big data testing, we would be, let's suppose a customer needs all the data to be generated from one directory, and that directory is used to fetch all the data on a graphical mode. Let's suppose, I'm again taking the GUI example. All the data being fetched is to be visualized on a GUI, wherein there are different columns. I'll again take the example of CDR. CDR has mobile number, customer name. So there has to be all the columns filled, all the rows filled with all the corrected data. No space, no special characters, nothing like that. In case of mobile number, let's suppose. So all the testing would go around that we have a 10-digit number and nothing beyond that. So we can just extract that error or some corrupted data. Maybe I'm saying corrupted because space is not been taken by the billing system. So that is a incorrect data which I have. So that kind of validation I need to put. So there are millions of records. I cannot validate or verify those millions of records going one by one, row by row. So I have to make my application robust enough to test all the things, all the numbers, all the columns, all the rows, so that my billing system is accepting all the records. If billing system will not accept any record, I will lose my revenue, obviously, because every CDR is associated with some cost, right? So big data testing is around it, and normal functional testing is around specific requirements. Like if I click on submit button, I go to a page, and then I click on a savings bank, then I have very limited scope of data there. So I can visualize it just by visualize it manually. No tools is required in that case, and in big data, we might require for a normal big data testing, we might require a tool because we cannot visualize it normally. All right.
So this is something related to big data technologies, like the concept which is involved in big data. We have MapReduce, we have NoSQL databases, and we have messaging queues. So the software tester at least should know some concepts of some little bit concepts of MapReduce, NoSQL, messaging queues, how it works. Like if I talk about MapReduce is basically a programming model or an implementation for processing and generating large data sets. So it basically involves a map function that would be involved in sorting, we want to capture some same kind of data out of something. Like we have a table, and that has some information about the name of the students or anything. So we want to sort that information. That is the main function of map. Map is a function wherein that is involved in sorting the data, and reduce is a function wherein it will give you count how many number of students that we have in the table. So we want to capture some information I have a string wherein that says Hadoop. So I want to know how many O's are there in that, what is the, how many H's are there. So all this is taken care, the pattern of data that is being involved, like while we are traversing the data, that is basically involved in MapReduce. And these are the various implementations of MapReduce. Apache Hadoop is an open source implementation. That's an open source framework, and that is an emerging stage as of now. Cloudera is a organization, and that has developed its own implementation of MapReduce, wherein they have customized the things around, and they have done some tweaking. Various concepts that are involved, and similar is the case with the Hortonworks also. Hortonworks, they have also released their own version of like this MapReduce. So these are the different implementations of MapReduce, and this is one of the very important technology that works or that is required for the working of big data. NoSQL databases, NoSQL or not only SQL databases. Actually, these are the databases that are required for the storage or the retrieval of information that is not in the regular like traditional RDBMS that we have in a table format or in a proper format. So these are the databases that are required, wherein they can fetch the information in the data, like wherein we don't have information in the proper format, in the form of proper tables or in the tabular format. So these are the two, like we can classify the types of databases on the basis of data models in the NoSQL. So primarily we have mentioned here Cassandra and MongoDB. Cassandra database basically follows the wherein there is a concept of there is a data model involved. I'm not able to recall the name. And in MongoDB, basically, we focus more on the document, like document data model is used in the case of MongoDB. And we have some other DynamoDB, we have some other NoSQL databases. So NoSQL database is one of the